today we're going to learn how we can linearize nonlinear relationships, and what this is going to allow us to do is actually use linear regression on nonlinear relationships. Okay. But let's see how we're going to do that. Okay. Let's start off with our data set. Okay. So I'm going to import that. So home, and this file is on Canvas now, so you can go in there and download the file. But let's import it here. I have it on my desktop, and it's this coronavirus cases, and it's just loading here. There we go. And all I actually want here are the first two columns, so I'm going to just highlight those. There we go. And I'm going to import that. Okay. And you can see here it says the following variables were imported, so I can close out of here now. Okay. And you can actually see it right here. Okay. But you can see again it's labeled as a table. So we want to go table to array. That way we can work with this data here. I'm going to just copy and paste the name right here. There we go. Alright, and let's just call this data. And let's first maybe say that the x data, okay, so x equals data of, and this would be the first column. Okay. And y, this would be the second column. This would be the number of cases. There we go. And let's go ahead and plot this and see what we would want to fit this with. Does it look linear? Does it look exponential? What's it look like? Okay. So x comma y. And I'm going to put some labels on this too. X label. Okay. And y label. And let's go ahead and give this thing a run. Okay. But no, I do not have up here the clear all, close all CLC, mainly just because I don't want the clear all there. I want to hold on to this data set here. I don't want to have to re-import it. Okay. Let's go ahead and hit editor and run. Okay. Oh, and I just made it the color red. Let me use the asterisks. Okay. There we go. There we go. Now we can see our data points. And yeah, this looks more exponential than anything else here. Okay. So it makes sense for us to try and fit this data with something that looks like this. Y equals alpha times e to the beta x. But what we're going to do is we are going to linearize this. And let's go ahead and put some comments in here real quick. Okay. So the x data is in weeks, and the y data is in cases. Okay. I just want that to be there, and I'm going to add one more comment. Alright, so that all looks good, but I'm going to comment out this plot here because we do not need it right now. Okay. And I want us to, again, linearize our data. Okay. But before we do it to the data, let's do this to the equation. So I'm going to grab this equation we have here. And let's see what that would look like. We are going to take the natural log of each side. So we get the natural log of y is equal to the natural log of alpha plus the natural log of e to the, and actually I'll write it exp of beta times x. Okay. And write the natural log and e undo each other, so this becomes the natural log of y, which actually, maybe I should just start writing it this way because MATLAB is going to prefer it this way. I'm going to say log. That's right, log is the natural log in MATLAB. All right, is equal to log of alpha plus, and this should be just beta times x. Okay. And now notice that if we were to let y equal log of y, and how about if we were to let a equal log of alpha and b to equal beta. So I'm going to get rid of one of these ands here. Then what's our equation look like? Okay, is the question. Well, it's going to look like big Y is equal to A plus BX. Okay. So if we make these little substitutions here, we have something that looks like a linear equation now. Okay. The only question is big Y here, okay, and X, are those two things going to be linearly related? Okay. So let's check that out. Let's take the log of our y data. So let's maybe go ahead and call this maybe log y. Okay. It's just going to be the log of the y data. Okay. And now is what I want us to do is to take a look and see if this looks linear. Because that's what we need. We need these two things to look linearly related. So I have x and then log of y. Okay. And let's do the asterisks again. And run. Okay. And let's see what we got going on here. Looks like we just need a lowercase y here, that's all. Okay. Oh, and right here, if I switch this to log big Y, there we go. I have some of my notation a little mixed up there. Okay. All right, so there it is. And so this isn't looking at this little section right here, kind of in between 1 and 5, kind of throw off what appears to be kind of a linear relationship. But let's just go ahead and give it a try. Let's try and use Polyfit to come up with a line that would fit this well, and then we'll convert it back in terms of alpha and beta and see how it actually fits the original data. Okay. Let's go ahead and use that Polyfit though. Okay. So Polyfit, okay, we'll take x and log of big Y. And we want this to be a first degree or yeah, first degree polynomial, meaning just linear. Okay? And remember, this is going to give us the coefficients, okay, of that polynomial. And so if we wanted to give this thing a quick plot, we could say, let's maybe choose x values. Actually, we'll just choose the x values from the x data. That's fine. We'll just take them from the data. Let's just set up our best fit line. Okay. Maybe I'll call it y line. Okay. And we'll want to take the first coefficient and multiply that one by x, okay, and then plus the second coefficient, okay, right? When you use Polyfit, it's going to go from the coefficient that goes in front of x to the highest power down to the constant term of the polynomial. Okay. So this should be enough here for us to generate a nice little plot. So we have x, we have y line, and let's maybe make that red. And did we have our, yeah, we have our plot for the original data here. I should say linearized data. Let's put a hold on. Let's go ahead and run. Looks like I misspelled something. So coefs. There we go. So it looks decent. Looks decent. Let's go ahead and unlinearize this and see how it looks. Okay. And so let's comment this stuff out here now too. Okay. Well, so to unlinearize this, I'm just going to write convert back here. What are we going to need to do? Okay. So we had, let's maybe start off with this a here. A was equal to log of alpha. So that means that alpha is equal to e to the a. Okay. What else do we have up here? We have b is equal to beta. Okay. So there's no need to change anything there. And these are actually the only two relationships that we need. Okay. Let's go ahead and see, or copy and paste what we wanted it to look like here in the end. Here it is. And actually, I'm going to take some of this stuff out of the comments. There's our alpha and our beta, which I just need to switch the order of. Actually, I'm not even going to do anything there. We already have found beta, and we found it in one of these lines that I need to uncomment. I meant to only comment out the graphing stuff here. Let me see if there's anything else here. So I am going to uncomment this coefs calculation here, and I think that's it. Okay, but the whole thing is that we were calling the thing in front of x here, coefs 1. If we were to go back up here, calling that b. So coefs 1 is equal to b, okay, or beta. So I'm going to write that beta is equal to coefs 1. Okay. And up here, I never wrote what a was equal to. A is supposed to be the constant term, and that's coefs 2. Okay. So we have A calculated, which allows us then to compute alpha. And then B and beta were equal to the same thing. So I'll just write beta equals coS1 without even mentioning B there. And lastly, maybe let's take a look at the plot. Okay, let's maybe uncomment the original plot here. Let's just go like that. There we go. And we'll also need a hold on here. There we go. All right, and I think the only other thing I want to do is maybe change the name of my variables here. Let's maybe call this big Y. So I'll still use our x's from the data, just week by week. And then here we'll just be using what we get from our line here. And let's maybe make it red. Okay. And I shouldn't say line, our exponential function. Okay. All right, and there it is, and looks pretty good. Okay. And you can see it's not super smooth looking, and that's just because we only took one x value for each week. Okay. If we had decided we wanted this to look a little bit better, we could say big X equals lin space. I'll make this a big X. And I think we were going from week 0 to week 10. So I'll just say 0 to 10, and let's pick some more points here in between. How about 25? Okay. And we ran into some issues because I haven't switched this X yet. There we go. Now it looks smooth, and you can see it fits the data pretty well. And the nice thing is we were able to still use linear regression in order to fit an exponential.